Hello everyone, my name is Amanuela Buhai. This is my master's project presentation. My topic is a spatial analysis of available hospital beds relative to the population distribution in Texas using adaptive bandwidth log relative risks. My advisor is Dr. Michael Tiflis-Groff, and I would like to thank you, Dr. Tiflis-Groff, for his great support and advice in achieving this project. My motivation is newspaper articles frequently discuss healthcare access in Texas. For example, the Houston Public Media or the Dallas Morning News. According to these articles, Texas has ranked last in public access and affordability. And the Texas Department of Health and Human Service predicts statewide shortage of more than 3,000 primary care physicians in Texas. So the objective of this study is it identifies counties which possess a significant over or under supply of hospital capacities relative to the demand of their underlying population, and potential causes for unbalanced distribution are evaluated. Study design, in contrast to other studies, a supply and demand approach is adopted in this study to evaluate the spatial disparities in the provision of health care. And kernel density smoothers are used because several counties have no have no hospitals, and to allow for cross-county spillovers for the supply and demand, and to account for a diverse population in a state as heterogeneous as Texas. Adaptive bandwidth needs to be employed. This map shows the population density of Texas. As we can see from this map, it's the population density is highly heterogeneous, with high population densities around DFW, Austin, San Antonio, and Houston metropolitan, and highly sparsely populated areas around West and Central Texas. So the capacity weighted kernel densities of the hospital distribution is compared against the population weight density of the block group centroids, and GIS technology and statistical methods available in several R packages are employed in this study. Relevant maps. This study data were obtained from Caliper Inc., a subset of 655 Texas hospital locations with 74,000 beds are used, and Texas has 15,799 census block groups with their population counters, number of veterans, and Army personnel is needed to evaluate the demand for hospital beds. And Texas 254 county polygon with relevant attribute information is applied to identify potential determinants explaining the disparities in hospital accessibility. This is the map of hospital distributions in Texas. As we can see from the map, it's highly clustered around highly populated metropolitan areas, and it follows the population trend. There are some counties which does not have a hospital. Data preparation, selection of valid hospitals. So only those hospitals which serve the general population are included in this analysis. So the hospitals for veteran and U.S. Army were removed because they serve specialized groups, and some closed beds, some hospitals which are closed have been removed, and this left 521 hospitals with around 64,000 beds. Definition of the target population: since the Army personnel and veterans are frequently visiting specialized hospitals. Uh, their population count is removed and only civilian population is used. And the map is projected into UTM zone 14, which is suitable for Texas. And the data is converted into raster grid using the uh, block group and hospital location centroids. It's converted into point pattern objectives with a raster resolution of 5 kilometer by 5 kilometer. Weighted adapted kernel density for a given set of sample locations S1 up to Sn and weights up to W1 up to Wn. The adaptive kernel density bandwidths are calculated into step processes. The first, using the fixed bandwidths, the density of the weighted point distribution at each pixel is explored by this formula, and then the adaptive bandwidth at each location SI is calculated using the exploratory density. Hospital surface. The hospital surface is calculated using a starting fixed bandwidth of 20 kilometer and with hospital beds. As we can see from this plot, the adaptive bandwidth clearly varies around the fixed starting bandwidth of 20 kilometers in areas with a dense placement of hospitals, which is the dark blue area. The adaptive bandwidth drops to 10 kilometers, which is equivalent to 6 miles, which for urban areas it's equivalent with a drive time of 20 kilometers. In contrast, for sparsely rural areas, the adaptive bandwidth increases to 100 kilometers, which is equivalent to 60 minutes drive time in rural or sparsely populated areas. In the block group surface, and for a block group surface, the selected 15 kilometer starting fixed bandwidth was selected after uh, repeatedly trial and errors. Uh, it leads to a low relative risk surface without major artifacts and a balanced distribution for log relative risk surfaces. So I have experimented different fixed starting bandwidths, and also for the block group, the adaptive bandwidth varies from 5 kilometer for the highly populated urban areas and to the sparsely populated area it varies up to 75 kilometers. So the selected fixed starting bandwidth of 15 kilometer gives a well smoothed surface. Log relative risk surface. The log relative risk compares hospital bed density against the population density estimates. Uh, Based on this formula, we get the log relative risk surface. So the interpretation is if the log relative risk is greater than uh, 0, it's oversupplied. If it's approximately 0, it's balanced, and if it's less than 0, it's underserved. As we can see from this map, the pixel layers with red color shows the oversupplied areas, whereas the blue areas, the blue colored pixel shows the underserved areas. In addition to the pixel map, we can also see the contour value, the p-value based on asymptotic value. Here the p-value shows the amount of risk. That means as the p-value is smaller, that means the area is underserved. For example, here we have 0.05 for the blue area, and we have zero point 0.5 up to 0.95 for the overserved areas. Hospital accessibility by county. The individual log relative risk pixel estimates are aggregated into county level because most of the policy are done on county level, and the following variables are subsequently used. So the average log relative risk value or the density is calculated. This will be the target variable in the subsequent regression analysis, and the variance of the pixel values within each county will be used as to calculate, to model the heterodicity within the regression model. So um, this is the function to convert uh, each pixel on a county level. In this map, the discrepancy map shows the between hospital beds, supply and demand surfaces. As we can see from this map, the blue areas are underserved, which are in the southern Texas and West Texas near El Paso, and all the metropolitan areas and surrounding counties are underserved, whereas the sparsely populated counties in central Texas are overserved, and some in uh, South Texas as well. Model identification, relevant explanatory variables. At the first step, the influence of potential explanatory variables on the spatial disparity of hospital accessibility is explored. So the political orientation of the county may indicate a potential leverage to obtain funding for local hospitals, as well as general mindset of the county's population towards the healthcare. And high proportion of uninsured population stresses the health of the healthcare supply. And counties with older population will demand more healthcare. The birth rate have the birth rate have a negative impact. Distance to Mexico doesn't seem have any impact, and here the poverty have negative impact for the access. Another important factor is urban-rural disparity. As we can see from this box plot, the light urban areas have higher median access, followed by rural and urban areas, and the metropolitan areas have lower access. Uh, Dominant regional disparity from this box plot, we can see that Edward Plateau and High Plateau have higher access than the East Texas as well as South Texas with a few outliers. So this shows the regional disparities. Another important factor is religious adhesion. As we can see from this box plot, as the population is becoming more religiously affiliation, so the supply, I mean the supply of or the access of hospital increases. This is maybe due to communities look out for each other. So the key finding is the plot metrics indicates that the political orientation of a county is highly relevant, and also most other variables. And the box plot highlights as the county's religion adhesion influences the provision by hospital beds as well as the regional variation. Heteroscedasticity regression model due to the calculation of the dependent variables of the log relative risk densities as average pixel value within the county boundaries. A variance is also associated with this density. So this causes heterodasticity in the regression model. So the employed regression model accounts for this heterodasticity variable. So this shows the summary of the heterodasticity model from the proposed set of initial variables. The interpretation of the heterodasticity model shows the significant positive gamma coefficient of the log relative risk variance demonstrated that, as expected, the residual variance increases with the variance of the county's log relative risk estimate. And the counties leaning to Republican have better access to hospitals, and counterintuitively, uh, as counties further away from Mexican border have less access to hospitals, and the Afro-American population is better served by hospital beds. This is either due to higher demand or political leverage. And with growing religious adhesion, the provision of hospital bed is increasing. Modeling diagnostics, the investigating nonlinearities as the Republican counties have higher access as well as uh, the Afro-American, as well as here with the religious adhesion, the group are more religiously affiliated, they have higher access. This shows the residual process and the residual diagnostic map shows uh, there is no significant outliers except these few outliers. That means all the Bonferroni p-values remain insignificant. And the residual normality, as we can see from this plot, the residuals are normally distributed with none of the standardized residuals are outside of the envelope. In the spatial residual diagnostic, the spatial pattern, this map shows the residual pattern of supply and demand model. As we can see, this map is highly clustered and which shows there is high spatial autocorrelation, and the weighted residual patterns exhibit substantial spatial clustering in the regression residuals. And the correlogram shows there's a with these outliers and a positive autocorrelation. And the uh, correlogram of supply and demand shows it highly variant, which means it's not random. It's clustered. Uh, so the slowly vanishing and perhaps oscillating autocorrelation level of for increasing spatial lags in correlogram indicates that the underlying data generating mechanism is more complex than we'd expect, either for simultaneous autoaggressive process or spatial lag. Uh, The conclusion, this study has shown while the travel distance in rural Texas are substantially longer to obtain access to healthcare, that the provision of healthcare relative to the population density is adequate for most areas, and adaptive bandwidth kernel estimation is preferred over fixed bandwidth for regions that is highly heterogeneous as Texas. For urbanized areas, average travel distance was around 10 kilometers, while for rural area it's around uh, 10 kilometers or 60 minutes travel time. Sparsely populated rural counties in central and panhandle uh, were relatively oversupplied. Republican political affiliation have of Republican political affiliation of counties have higher supply of hospital beds. Future study ideas. So rather than using the adaptive weighted kernel densities based on Euclidean distance, densities based on the travel time along the street network can be evaluated, possible across the state line and perhaps even across the international border, can be accounted for by adding a buffer around Texas. And having this analysis encoded as a R markdown document easily enables reproduction of this study for an augmented data set. And these are the references that I used for this project. Uh, if you have any question, you are welcome. Thank you very much.